In this problem, a 25-gram bowl of zinc is heated, and then it's placed in a calorimeter, the water temperature increases, and we're given the specific heat of the zinc. It's asking us to find the initial temperature of the zinc metal. So how hot was the zinc metal before it was dropped into the water in the calorimeter? So right away, what I'm going to do is make a table to organize the information that we have in the problem. So I know that Q equals M times C times delta T, which is T final minus T initial to give us delta T. And I'm going to have these pieces of information for two different samples. We'll have this for the zinc, and we're also going to have this for the water. And so this is just a lot of information, and I think it helps in these calorimetry problems to organize the information before you start plugging things into an equation. So here is all of my information organized into a table format here. Okay, so a 25-gram sample of zinc, so that would be the mass of zinc, 25.0 grams, is heated and placed in a calorimeter containing 65 grams of water. So that would be the mass of the water. The temperature of the water increased from 20.00 degrees, so that's our initial temperature, is 20.00 degrees C, to 22.5 degrees Celsius. The specific heat of zinc is 0.390 joules per gram Celsius. And I'm not going to write the units there because it won't fit in my table. What was the initial temperature of the zinc metal? So we're asked to find the initial temperature of the zinc metal, and it tells us the final temperature of the water and the zinc are the same. But even if it didn't actually tell us that, we could know that because we know that heat will continue to move until we reach an equilibrium temperature. So we'll just kind of move that up into the right place there. Now we have all of our information written out into this table format, so it'll be a little bit easier to keep track of as we go through the problem, and it also is helpful when trying to figure out how many sig figs your answer should have. So we know the final temperature is the same for both of these. Okay. We know the specific heat of liquid water is 4.184 joules per gram degree Celsius. So we have a whole lot of information here. We have everything we need to find the heat energy that is absorbed by the water. So we'll go ahead and figure out our delta T. And when we do this calculation, we're going to have to round our answer to 2 decimal places because that is the sig fig rule. And so we get 2.50 degrees Celsius as our temperature change here. And so that means that when we do our calculation for Q, our answer can have no more than 3 sig figs. Because this has 3 sig figs, and then this also has 3 sig figs as well. So let's go ahead and calculate out the Q for the water. It's going to equal 65.0 grams times 4.184 joules per gram degree Celsius times 2.50 degrees Celsius of our temperature change. So our Q for our water, if we multiply all that out, I got 679.9, but of course we are actually going to round this to just 3 sig figs, so 680 joules here. So that means that if the Q for the water is 680 joules, the Q for the zinc must be the opposite sign of that. So it must be negative 680 joules. So we need to solve for the initial temperature of the zinc. So before we do that, we're going to have to solve for the delta T value. And so in our equation, Q equals mc delta T. I'm going to rearrange my equation by moving m and c to the left-hand side, so that way I have delta T by itself. So I have delta T equals Q divided by M times C. So negative 680 joules divided by my mass of my zinc, 25.0 grams, times my value of C, 0.390 joules per gram degrees Celsius. So when we solve this, let's see, 680 divided by 25 divided by 0.39, I got 69, negative 69.74. And we should have 3 sig figs in this value. So we'll go ahead and round to negative 69.7. And we do need to figure out our units. Our units should come out in degrees Celsius because this is a temperature. Our grams cancel, our joules cancel. So yes, indeed, our units on our answer are in degrees Celsius. But this is not actually the initial temperature. This is our delta T value. So this is not our final answer yet. We do need to figure out what our initial temperature is, and I know that our delta T is equal to the final temperature minus the initial temperature. So I substitute in the final temperature of 22.50 minus the initial temperature. That will equal our delta T value of negative 69.7 degrees Celsius. So right away I'm going to go ahead and transfer my negative signs. I'm going to multiply the whole thing by -1, so that way I end up with negative 22.50 plus T initial equals 69.7. We can accomplish this by just multiplying the entire equation times -1. So that's what I did first. That makes it a little bit easier to move my numbers to the same side. So I can add 22.50 to both sides. And then that gives me my T initial equals 69.7 plus 22.5. Which gives me 92.2. And since there's only one decimal point on the 69.7, we will round our answer to one decimal point as well, which has 3 sig figs, which does indeed match our initial number of sig figs. That worked out nicely. So our initial temperature is 92.2 degrees Celsius. And we will just box in that final answer. There we go.